Hello everyone. Till now we have studied continuity and I hope continuity is completely clear to you all. Now we will move forward to differentiability. The concepts of differentiability will be discussed in this video. The straight definition of differentiability is given as, suppose f is a real function. Real function means the function f is giving a real value, means the range of the function is a real value, and C is a point in its domain, any random point, arbitrary point C. The derivative of f at C is defined by limit h tends to 0, f of C plus h minus f of C whole upon h. So this is your expression to define the derivative of a function. Okay, now comes a keyword, provided the limit exists, means this expression should give you a finite value, means this should not be minus infinity or plus infinity. A finite value should be obtained. Alright. So this expression can actually be represented as x tends to C, f of x minus f of C whole upon x minus C. When you are checking the derivability of the function at any point C, this whole expression can be written as this also. Here your limit was tending towards 0, h tends towards 0. But when you transform it to x tends to C, because your function is fx, okay, when x tends to C, the expression can be written like this. And how has this come? Just taking the simple transformation, x is equal to C minus h. Alright, no, C plus h. X is equal to C plus h, that's it. So what happens? Your x becomes C plus h, okay, and x minus C becomes h, that's it. So this is your differentiability. If we talk in the layman's language, continuity is when you are able to draw any graph without lifting your pen. Okay, if suppose your function is fx, and if you can draw the graph of this function without lifting your pen in single stroke, then the function is continuous. This is how you check the continuity via graph. Okay, and when you talk about differentiability, that means if suppose fx is a function, you have to check the differentiability of the function. You will see that at the point where you are going to check the differentiability, your function should give a unique tangent. Okay, जिस पॉइंट पे आपको डिफरेंशिएबिलिटी चेक करनी है, उस पॉइंट पे फंक्शन के का यूनिक टेंजेंट एग्जिस्ट करना चाहिए. अगर आपको सपोज कोई ग्राफ ऐसे है, ओके, और आपको यहाँ पे डिफरेंशिएबिलिटी चेक करनी है इस पॉइंट पे, तो आपको खुद दिख रहा है कि यहाँ से तो मल्टीपल टेंजेंट्स जा सकते हैं इस पॉइंट से, यहाँ से ऐसे ऐसे. ओके, सो दिस ग्राफ इज नॉट कंटिन्यूअस. सो टॉकिंग इन द लेमैन्स लैंग्वेज, when you are able to draw a graph without lifting the pen, the function is continuous. When you are able to obtain a unique tangent through a point, then the function is differentiable at that point or derivable at that point. Okay, so important is this expression. Okay, and provided the limit exists, that means limit should not be minus infinity plus infinity. You should get a real value, a finite value. Now from the previous classes, you know that fx is a function. Okay, so how would you denote the derivative of the function? Simply by f dash x. Okay, or you would say dy dx, right? So the question comes, from where this expression come? How are you able to solve this? So for that, a concept of differentiability comes. This is expressed as, if you are to find the differentiability, the differentiation of the function in the terms of limit, then this can be represented as limit x tends to C, f of x minus f of C whole upon x minus C. Or if you change the limit, it goes to limit h tends to 0, f of x plus h minus f of x whole upon h. Alright, no, C, you are tending towards C. Okay, so this is how your derivative is represented in the limit form. Now since you are given that the limit must exist, so what happens when the limit does not exist? What happens in that case? So in that case you would say that your function is not differentiable, the function is not derivable if the limit does not exist. Now for this we will bring into the play the concepts of left hand derivative and right hand derivative. Okay, so left hand derivative of any differentiable function is limit h tends to 0 minus f of c plus h minus f of c whole upon h, and right hand derivative is limit h tends to 0 plus. Okay, so the major difference here is that in this case, left hand derivative case, you are approaching this point from the left hand side, okay, and in the right hand derivative you are approaching from the right hand side. So ultimately your function is going to be changed in most of the cases. We will see this through an example, but this is what it is. Left hand derivative is like this, right hand derivative is like this. Now the condition for this function to be derivable is that your left hand derivative should be equal to right hand derivative and must give a finite value. Any finite value, you must get a finite value in return. Now this is this p, whatever value you are going to obtain, this p is the differentiation of your function. Let us understand the concepts of left hand derivative and right hand derivative through an example. Okay, so here fx is a function defined as this, and you have to check the differentiability at x is equal to 2. Now here your left hand derivative and right hand derivative come into play. How? You know, when you have to check the differentiability at any point, your left hand derivative should be equal to right hand derivative and should give you a finite value. Okay, so this is your condition. So let us find the left hand derivative. You know what left hand derivative is, limit h tends to 2 minus f of x minus f of 2 whole upon x minus 2. Alright, so you are approaching 2 from the left hand side, means the function is going to have the value where x is less than 2. So that case your function is x minus 1. So you get limit x tends to 2 minus f of x is x minus 1, and the value at 2 is 2 to the 4, 4 minus 1, 1 means minus 1 whole upon x minus 2. So this is limit x tends to 2 minus x minus 2 upon x minus 2. Alright, so this is limit x tends to 2 minus of 1. Function is independent of x, so value is 1. You got your left hand derivative is 1. Alright, and now when you have to find the right hand derivative, okay, we are going to find the right hand derivative now. Right hand derivative means we are approaching x from the right hand side, x tends to 2 plus. Alright, so in that case, when you are approaching from right hand side means the value where x is greater than 2. The function's value is 2x minus 3. So it's 2x minus 3 minus value of the function at 2 is 1. Alright, and the denominator you get x minus 2. So this gives you limit x tends to 2 plus, this is 2x minus 4 whole upon x minus 2. This can further be simplified as, you take 2 common here, you are going to get x minus 2 upon x minus 2. Alright, so this is ultimately going to give you 2. Alright, because this will get cancelled and limit x tends to 2 plus 2 is 2 only. So you get your left hand derivative was 1, right hand derivative is 2. Both of them are finite. Alright, but not equal to each other. Okay, getting it? Left hand derivative is finite, although this is finite, and right hand derivative is also finite, but not equal to each other. Therefore, the function is not differentiable at x is equal to 2. Okay, therefore function is not differentiable, whatever it is, at x is equal to 2. So this is your conclusion. What you have to do? Check the left hand derivative, right hand derivative, and both should be equal. And the method to find left hand derivative and right hand derivative goes like this. Now comes an interesting property that says whenever your function is differentiable, this implies your function is also continuous. मतलब जब भी आप किसी फंक्शन की डिफरेंशिएबिलिटी की बात कर रहे हो, अगर फंक्शन आपका डिफरेंशिएबल है तो फर्स्ट ऑफ ऑल उसको कॉन्टिन्यूस होना ज़रूरी है. अगर फंक्शन कॉन्टिन्यूस नहीं है तो फंक्शन की डिफरेंशिएबिलिटी की बात ही नहीं आती है. डिफरेंशिएबिलिटी की बात तभी आएगी जब आपका फंक्शन ऑलरेडी कॉन्टिन्यूस है. दिस मीन्स डिफरेंशिएबिलिटी इम्प्लाइज कंटिन्यूटी. But when we talk about the vice versa of this theorem, that continuity also implies differentiability, means कि हर continuous function differentiable होगा. ये true नहीं है. This is not true. All right. So differentiability implies continuity holds for all the functions. But we will see this through an example that all continuous functions are not differentiable. So this is what your theorem says. Your theorem states that if a function fx is equal to y is differentiable at some x is equal to c, then it is also continuous at that point. Means function is also continuous at x is equal to c. So we will see how we have to prove this. What is given? Given is that the function is differentiable at c. That means limit x tends to c f of x minus f of c whole upon x minus c is given. All right. Is equal to f dash c. You know that your function is continuous, differentiable at c. Alright, so this can be expressed at this in the limit form, right? And now what you have to prove? That the function is also continuous at c. That means limit x tends to c f of x is equal to f of c. Alright, this is how you prove continuity. You know that? So this is given and we have to obtain this. It's given that the function is differentiable at c. That means x tends to c f of x minus f of c whole upon x minus c. Alright. What is our function? Our function is fx. Right. So let us try to manipulate this function. Okay, we are going to start. Let fx is equal to fx plus minus f of c and plus f of c. Alright. Look closely what we are going to do here. I started from my function fx and I am going to bring it in the form of f dash c. See how. Now this can also be written as f of x minus f of c whole upon x minus c. Okay, if you multiply one x minus c, you have to, no, if you divide one x minus c, you have to multiply one x minus c here. Alright. Plus f of c. Alright. What I have done? I have multiplied one x minus c on this expression, on this term, and also divided one. So it is equivalent to the above part. Now, we will apply limit x tends to c both the side. Limit x tends to c f of x is equal to, now you see, these are two functions, suppose gx and hx. So we will separately apply the limit. Limit can be splitted, right? So it becomes limit x tends to c. First of all, let's see, we are applying limit on both the sides. So this gives you limit x tends to c f of x is equal to limit of the whole expression. Alright, now what I will do, we'll limit, split the limit. Okay, so this becomes limit x tends to c f of x minus f of c whole upon x minus c into x minus c. Alright, plus limit of f of c. Alright, so till now we were given the function is differentiable at c. That means limit x tends to c f of x minus f of c whole upon x minus c. Okay, so कहाँ से हमने स्टार्ट किया, हमने अपने फंक्शन से स्टार्ट किया। फंक्शन को हम ऐसे मैनिपुलेट करने की कोशिश कर रहे हैं कि हमें अपना ये टर्म ऑब्टेन हो जाए, ये चीज़ हमें मिल जाए। तो व्हाट आई डिड, एक माइनस एफ ऑफ सी किया, एक प्लस एफ ऑफ सी किया, ऑल राइट, एंड देन यू कैन सी हाउ वी हैव प्रोसीडेड। अल्टीमेटली व्हाट आई हैव गॉट, लिमिट एक्स टेंस टू सी एफ ऑफ एक्स इज इक्वल टू limit x tends to c this whole expression plus limit x tends to c f of c. Now on further solving, your limit x tends to c f of x means your left hand side becomes, you see, you are going to apply x tends to c. Okay, so when your x is tending towards c, we will do one more thing here. These are two terms into multiplication, all right, these are two terms into multiplication. यहाँ पे भी हम लिमिट को स्प्लिट कर लेते हैं, तो ये एक्चुअली बन जाएगा लिमिट x टेंस टू c दिस f ऑफ x माइनस f ऑफ c होल अपॉन x माइनस c इंटू लिमिट x टेंस टू c x माइनस c. ओके, दिस टर्म इज इन मल्टीप्लीकेशन विद दिस होल टर्म, तो हमने यहाँ पे भी लिमिट x को स्प्लिट कर लिया है, प्लस नीचे क्या था, लिमिट x टेंस टू c f ऑफ c. ओके, अब देखो लिमिट x टेंस टू c f ऑफ x इज इक्वल टू, इन द फर्स्ट टर्म x टेंस टू c है, तो अगर यहाँ पे x टेंडिंग टूवर्ड c है तो ये टर्म आपका पूरा जीरो हो जाएगा, है ना, c माइनस सी जीरो, तो अल्टीमेटली जो ऊपर का टर्म है जीरो से मल्टीप्लाइड होके जीरो दे देगा, ऑल राइट, और बचता क्या है, ये वाला फंक्शन, ये इंडिपेंडेंट ऑफ x है, x इज टेंडिंग टूवर्ड c बट द फंक्शन इज इंडिपेंडेंट ऑफ x, so it is f of c only. Getting my point? For the first part of the expression, your x is tending towards c, तो इसको सॉल्व करोगे और इसको सॉल्व करोगे, यहाँ पे आपको जीरो मिल जाए, तो ये समथिंग a इंटू जीरो है, तो अल्टीमेटली इट इज जीरो। यहाँ पे फंक्शन इंडिपेंडेंट ऑफ x है, सो इट इज गोइंग टू गिव यू f ऑफ c ओनली, तो आपको क्या मिला, लिमिट x टेंस टू c f ऑफ c इज इक्वल टू f ऑफ x इज इक्वल टू f ऑफ c. सो दिस इज व्हाट यू हैव टू प्रूव इन कंटिन्यूटी. कंटिन्यूटी प्रूव करने के लिए यही तो करते हैं, तो देयरफॉर एफ एक्स इज कॉन्टिन्यूअस एट एक्स इज इक्वल टू सी. तो हमें गिवन क्या था, गिवन था कि फंक्शन डिफरेंशिएबल एट सी पे मैनिपुलेट करके फंक्शन को, सबसे पहले हमने फंक्शन को मैनिपुलेट किया, उसके बाद उस पर लिमिट लगा दी बोथ लेफ्ट हैंड साइड एंड द राइट हैंड साइड, and we obtained, we got that fx is also continuous at c. So this is what our theorem has stated. Now we will check the corollary of the theorem that we just discussed. The theorem said that every differentiable function is continuous. Okay, so corollary means the vice versa of the theorem. Now we are going to check whether the reverse is also true or not, कि हर continuous function भी differentiable है या नहीं. Okay, so for that it is enough for you to just pick one function and show it with the help of that function, मतलब show it or prove it with the help of one example, that is sufficient. Okay, so the best way to prove that every continuous function is not differentiable is the example of the very familiar function that you know, fx is equal to mod x. Everybody is familiar with this function, and in your continuity part you have already proven that fx is equal to mod x. This mod function is continuous. mod function continuous होता है, ये आपने continuity वाले पार्ट में पढ़ाई है. अब हम प्रूव करने की कोशिश करते हैं कि ये डिफरेंशिएबल है कि नहीं है, मतलब ये हम चेक करने की कोशिश करते हैं. ठीक है, f of x is mod of x. mod of x can be splitted as what? minus x when x is smaller than 0 and x when x is greater than or equal to 0. This is how your mod of x is splitted, right? So you know fx is continuous at x is equal to 0. 0 पे फंक्शन आपका कॉन्टिन्यूस होता है. अब डिफरेंशिएबिलिटी देखते हैं. हम लेफ्ट हैंड लिमिट, लेफ्ट हैंड डेरिवेटिव और राइट हैंड डेरिवेटिव चेक करते हैं व्हेन योर पॉइंट इज अप्रोचिंग 0. अब 0 पे ही हम लेफ्ट हैंड डेरिवेटिव, राइट हैंड डेरिवेटिव देखते हैं. ओके, सो लेफ्ट हैंड डेरिवेटिव इज व्हाट, लिमिट h टेंस टू 0 माइनस f ऑफ x प्लस h माइनस 0 प्लस h, क्योंकि पॉइंट हमारा क्या है 0. 0 पे कंटिन्यूस है ना, तो 0 पे डिफरेंशिएबिलिटी चेक कर रहे हैं हम, तो पॉइंट तो 0 है तो रिप्लेस कर देते हैं. वैसे तो आपका फॉर्मूला क्या होता है, फॉर्मूला ये होता है लिमिट h टेंस टू 0 एफ ऑफ सी प्लस एच माइनस एफ ऑफ सी होल अपॉन एच, ये फॉर्मूला होता है, ठीक है। अब लेफ्ट हैंड डेरिवेटिव के केस में लेफ्ट हैंड साइड से जीरो को अप्रोच करेंगे और राइट हैंड डेरिवेटिव के केस में प्लस पॉजिटिव साइड से अप्रोच करेंगे, ठीक है। अब पॉइंट तो आपको पता है कि जीरो है तो सी को सीधा रिप्लेस करके जीरो कर देते हैं, ईज हो जाएगी। तो फंक्शन आपका ऐसे बन जाता है, ये एक्सप्रेशन एफ ऑफ जीरो होल अपॉन एच। ऑलराइट, सो व्हेन यू आर अप्रोचिंग जीरो फ्रॉम द लेफ्ट हैंड साइड, मतलब कि जीरो के लेफ्ट हैंड साइड से आ रहे हो तो एक्स लेस देन जीरो पे देखोगे ना, एक्स लेस देन जीरो पे फंक्शन की वैल्यू माइनस एक्स है, मतलब लिमिट एच टेंस टू जीरो माइनस फंक्शन की वैल्यू क्या हो जाती है, माइनस ऑफ एच बन जाती है। और जीरो पे फंक्शन की वैल्यू क्या है, जीरो पे फंक्शन की वैल्यू एक्स ही है, मतलब जीरो पे वैल्यू जीरो ही होगी अपॉन एच। सो दिस गिव्स यू माइनस एच अपॉन एच इज इक्वल टू -1। ऑलराइट, राइट हैंड डेरिवेटिव ऐसे ही सेम हम फाइंड करते हैं, लिमिट एच टेंस टू जीरो पॉजिटिव, ठीक है, एफ ऑफ जीरो प्लस एच माइनस एफ ऑफ जीरो होल अपॉन एच। ऑलराइट, सो अब जीरो को राइट हैंड साइड से अप्रोच कर रहे हैं तो एक्स ग्रेटर देन जीरो पे फंक्शन की वैल्यू देखेंगे ना, ये क्या हुआ, जीरो प्लस एच मीन्स व्हाट, अल्टीमेटली एच एफ ऑफ एच ही देखना है, और फंक्शन की वैल्यू राइट हैंड साइड से एक्स ग्रेटर देन जीरो से वैल्यू क्या है, एक्स ही है, मतलब एफ ऑफ एच इज एच, एफ ऑफ जीरो इज जीरो अपॉन एच इज इक्वल टू 1। ऑलराइट, okay, got it? So left hand derivative is -1, right hand derivative is +1, therefore left hand derivative, right hand derivative are not equal to each other, hence the function is not differentiable at 0। देखो जीरो पे आपका जो पॉइंट x इज इक्वल टू जीरो हम चेक कर रहे थे, इस पे लेफ्ट हैंड डेरिवेटिव इज नॉट इक्वल टू राइट हैंड डेरिवेटिव, राइट, दो द फंक्शन इज नॉट डिफरेंशिएबल एट जीरो, हाँ, so the function is ultimately not differentiable, therefore fx is not differentiable or derivable। Alright, so fx was continuous, fx is continuous function but not a differentiable function, so your corollary is not true। थ्योरम का जो रिवर्स पार्ट है, वाइस वर्सा पार्ट है, वो ट्रू नहीं है। तो आपको रिजल्ट क्या मिलता है कि हर डिफरेंशिएबल फंक्शन आपको कंटिन्यूस होगा, पर ज़रूरी नहीं है कि हर कंटिन्यूस फंक्शन डिफरेंशिएबल हो, वो आपने प्रूव कर दिया मॉड ऑफ एक्स का एग्जाम्पल लेके। सो दिस इज ऑल अबाउट डिफरेंशिएबिलिटी। ओके, रीड अ लॉट एंड डेवलप योर ओन कॉन्सेप्ट्स। अभी थोड़ा सा आपको शायद ये क्लमजी लग रहा हो देखने में, पर आप खुद से पढ़ोगे और आप खुद जब ये कॉन्सेप्ट्स अडॉप्ट करोगे तो ये बहुत ही सिंपल है, सिंपल इन द सेंस बहुत इंटरेस्टिंग है, नंबर लाइन पे है, पूरा रियल मैथमेटिक्स है, प्योर मैथमेटिक्स है, तो इंटरेस्टिंग पार्ट है। तो रीड अ लॉट। ओके, थैंक यू।